1951. The Valley of the Camano. Alcan crews had started construction on the aluminum project in British Columbia. 800 square miles of unused wilderness awakened out of the silence of time. Men began to gouge roads, build camp cities, and blast access tunnels, preparing the ground for hydroelectric development to provide the tremendous electric power needed in the manufacture of aluminum. Power that would maintain Canada's place in the world as a producer of aluminum. Thousands of engineers and construction men, billions of dollars worth of equipment moved into the area. To establish this new industry in British Columbia, it was planned to dam the Nechako River and form the essential reservoir in the tributary lake area. Then, 120 miles to the west at the end of Tatsa Lake, tunnels would be driven through the granite of a mountain range to channel the reservoir waters into the Valley of the Camano, where a great underground powerhouse would utilize the falling waters to create electrical energy. From here, a transmission line was planned to carry the new power 50 miles over the rugged terrain to Kitimat, the location for the new plant and town site to be one day the western center of Canadian aluminum. Access into a project of this scope is often difficult. On the Alcan project, every mile of road was a hard-won battle with nature. Several hundred miles of access roads were built to open the wilderness. In from Burns Lake, 120 miles of highway were built to meet a barge service on Tatsa that linked the tunnel inlet with civilization. And further east, another road was pushed down from Vanderhoof to the Grand Canyon of the Nechako, where construction on the new dam was underway. Early in 1951, giant machines were laying bare the foundation for the dam. Unused waters of the Nechako River would be harnessed to serve the needs of Canadians. First, a tunnel was to be blasted to divert the course of the river and allow engineers to get down into the canyon river bed. A few months later, as winter had settled down upon the canyon, the tunnel was completed. Engineers devoted their full attention to the temporary diversion of the river through this new underground course. At this time of the year, the river was at its lowest level, but still the swift current obstructed the building of a cofferdam. Thousands of tons of rock and dirt were dumped between the steep walls into the gap of the canyon. As the gorge narrowed, the current increased. Trucks kept on with the fill, and finally their objective was accomplished. On October 24th, 1951, a well-placed charge tore out the narrow barrier of rock over the mouth of the diversion tunnel. The river flowed through its new channel. Engineers had won the first round in their battle to stop the river. Through early spring of 1952, an examination and tests in the old riverbed revealed a foundation of solid rock. Hard rock men scoured the canyon walls and riverbed. Thousands of holes were drilled deep into the bedrock, and cement was forced in under high pressure. Every crack, every joint in the rock was filled to produce a solid, impervious foundation so that contractors could build the massive structure of the dam. Meanwhile, in the lake area, 60 miles to the west, other crews faced problems of their own. A barge service was to be established to carry men and supplies up and down Tatsa Lake. These barges, built in Vancouver, were shipped by railway and road and assembled in the lake area. Now the problem was to get them up the narrow Tatsa River and into their permanent place of service on Tatsa Lake. Treacherous currents of this unknown stream threatened disaster. Shoals, hidden rocks lurked at every turn. 5 days of fierce struggle to gain the quiet waters of Tatsa Lake. With the barges in service, the wilderness camp at the base of the mountain soon grew into a small city. At this site, the tunnel had been driven into the face of the mountain, and deep underground, hard rock miners were blasting their way toward Camano. It was going to take time to drive a 10-mile tunnel through a mountain range. As work in the tunnel progressed, camp facilities expanded to include many of the comforts of city life. In the sunlight above ground, miners' families found life in this mountain wonderland a pleasant experience, and school was worth attending, even if it was only to have fun at recess. Winter at Tatsa brought deep snow, but in this city of machines, snow was a minor problem. Underground on the tunnel job, seasons are all the same, and a steady stream of loaded mining cars coming out to the surface showed that miners were getting on with their job. At times during winter, because of the deep snow, the only contact with the outside was by air. Planes maintained the best possible schedules carrying men and supplies between Tatsa and the main camp at Camano. Here in the valley of the Camano River, Alcan construction crews had also put their mark upon the wilderness. A wide cut cleared out of the bush of the steep mountainside marked the access route to the tunnel outlets. And below, at the base of the mountain, another camp city spread out over the valley floor. But here, as at Tatsa, the real story was underground. Inside the mountain, miners were carving a network of tunnels and excavating a powerhouse for the production of electrical power. 1,600 feet up the mountain, an entrance had been driven into the slope, and farther up at the 2,600-foot level, another passage led into the main power tunnel. Serving the needs of miners at these upper levels was a problem in vertical transport, adequately solved by the installation of an aerial tramway. Capable of carrying large tractors to the mountaintop, this represented another heavy investment in access equipment. At the top of the tramway run, 2,600 feet above the Camano Valley, a railway ran along a narrow ledge and vanished underground into the main power tunnel. Deep inside the mountain, miners blasted the headings forward in record-breaking drive. In one day, one of the 4 tunnel headings was driven forward a distance of 61 feet, a world's record, and an achievement that pointed clearly to superior organization and the closest teamwork. Early in 1952, a steamer docked at the Camano Deep-Sea Wharf, and a delegation of prominent businessmen, sponsored by the Vancouver Board of Trade, came ashore for a tour of the project. These men, taking pride in Canadian accomplishment, were naturally interested to see how Alcan was progressing with a project of such immensity. Deep in the mountain at Camano, a cavern to be ultimately 1,142 feet long was being excavated to form the underground powerhouse. In the darkness, laymen watched as miners removed the blasted rock from the powerhouse cavern. On the surface, the quiet mountainside belied the fever of drilling that shook its interior. Underground, an excavation large enough to hold the liner Queen Elizabeth and a complex series of tail race and penstock tunnels were being excavated. Miners who worked in this underground maze, whose efforts broke world records in driving of power tunnels, were pleased with their home in the valley. The camp at Camano provided many modern conveniences for the men and women engaged in this project. In rugged coastal British Columbia, supply is a major problem. On the transmission line, helicopters were used to fly men and material into the camps scattered along the route. This transmission line will carry the tremendous power up over mile-high Kildala Pass and onward to the plant site at Kitimat. Its aluminum conductor cables, 2 1/4 inches in diameter, will be the largest ever used for overhead power transmission. Alcan top executives and engineers made close personal inspections, for this transmission line is regarded as a Canadian achievement, one of the engineering feats of the project. Rugged terrain for transmission. Nevertheless, in time, 1.5 million horsepower will be dispatched over this barren pass to make aluminum in the smelter at Kitimat. Sprawling over the delta of a 70-mile inlet, Kitimat too reverberates with the roar of powerful machines. Soon, its deep-sea harbor will give space to ships from world ports with cargoes of raw materials to make aluminum. Today, an hydraulic dredge is taking silt from the bottom and spreading it over the low-lying delta with the double purpose of deepening and filling. Fill is no problem at Kitimat. 3 miles from the construction site, a natural mountain of sand and gravel rises out of the river valley. Giant trucks carrying 30 tons in a single load roar over the roads day and night, hauling this material to the site. Here, where in time the great buildings of the smelter will rise, Carpenters work over the forms, and 24 hours a day, massive trucks keep a steady stream of concrete pouring into the mold. Spread over a total of 100 acres, the first stage of the Kitimat smelter will mean a new way of life for thousands of Canadian men and women employed in the production of aluminum. That production will reach over 500,000 tons yearly with the project's ultimate completion. The young city of Kitimat will take its place in this group of western communities and make an important contribution to the economic development of the area. Today, overlooking the site of the new aluminum plant, a camp city feeds and houses over 1,400 construction workers. This modern cafeteria is the largest dining hall on the project, but feeding 600 men at a time is a project all in itself, and the stampedes that shake its frame pay regular tribute to the excellent fare. To block the Nechako River, the fill for the Kenny Dam required the blasting and trucking of millions of tons of rock. The endless stream of trucks that did the job worked between the quarries and the dam without let-up either day or night for 5 solid months. With the possibility of an early winter, pressure was on to reach a stage where control gates could be closed and water storage commenced. Every level of this man-made mountain swarmed with machinery. Man did the thinking, provided direction, acted as the nerve center of operations, but machines did the heavy work. This dam, when completed, measured 300 feet in height from the old riverbed, a quarter-mile wide at its base, and 1,500 feet along the crest line. A veritable man-made mountain. By early October in 1952, and right on schedule, construction engineers on the Kenny Dam announced that the time had come to start the storage of water. While it was conducted in a routine manner by men on the job, the closing of these gates would signify the achievement of an important stride in this project to make aluminum in British Columbia. On October 8, 1952, a busy crew assembled around the gate. This was the day. Without fanfare or ceremony, the great concrete slabs lowered slowly into place, cutting the Nechako and turning its waters into useful surface. Tractors lost no time in pushing the fill in to complete the closure. And with this, the short service of the diversion tunnel came to an abrupt and permanent end. A plug of solid concrete was poured into the tunnel behind the gates, sealing them forever against the frailties of man and the ravages of time. Slowly the river rose. Inch by inch it began to creep across the toe of the new dam. Waters that had flowed unchecked through centuries now began to conserve energy for a mighty enterprise 150 miles to the west at Kitimat. The first major objective in British Columbia's Alcan project had been achieved, but still the work goes on. Completion of the Kenny Dam struck a resounding chord in the Prelude to Kitimat, echoed across this land of the giants, to the intake at Tatsa, into tunnels at Kamano, all over the vast project, to the day when waters will surge through a mountain and their power will flash over the pass to a grand finale in the smelter at Kitimat. Across this great terrain, Canadians are putting to use the power of water to start a new British Columbia industry, to make an essential and expanding product, aluminum, bearing the well-known mark Alcan, made in Canada.